Good morning and welcome to Tech 240 for Wednesday, January 13th. If you're watching this video, then I guess that means I didn't scare you off too badly on Monday, so that's a good thing. Before we jump into any topics, let's take a look at the schedule, which I have printed out, and I'd recommend you do the same. And I just keep it at the very front of my lab manual binder. So if we look at the January 13th row, we see that we have quiz 1 due on January 17th. That's this Sunday. And it's due at 11:55 p.m. So don't forget about that. That's a pretty easy quiz. It's some of the easiest points in the semester. A lot of that quiz is just about the syllabus and the schedule and the lab manual. So it's pretty straightforward. There are a few things in that quiz about the first two reading assignments that you see on the schedule, the first two reading assignments. So make sure you do those reading assignments and have the syllabus available for you to look at while you're taking the quiz, and you should be pretty good to go. All right, so that's the schedule. We have one more assignment there. Under quiz 1 due on January 17th, we have lab 1, which we'll talk about in one of the next videos today. Lab 1 is due on January 25th. So normally I give you a week to do the labs normally, but next Monday is MLK Junior Day and there's no class, so I'm giving you an extra day. So it's due on January 25th on Reginet by 11:55 p.m. Okay, so let's go ahead and get started. Today I think I'm going to make 3 videos, which is more than I will normally make, all right? So this is kind of an anomaly, but I think I'm going to make 3 videos today. The first video, this one, is going to talk about the LOTO, L-O-T-O, Lockout Tag Out system. And that is really a continuation of electrical safety that we started talking about on the first day, on Monday. So we're going to continue talking about electrical safety by talking about the LOTO system in this video. In the second video, I'm going to give you an orientation to the Tinkercad program. And that's really just to help you and set you up for success on the next couple of labs, because we're going to use Tinkercad in lab 1, lab 2, 4, 5, 6, and 7. So a bunch of labs coming up, you're going to use Tinkercad. So I want to make sure that you are all comfortable using that program. So I'm going to give you a little overview, and you can follow along. You can pause the video and follow along and do the steps along with me as we talk through the Tinkercad program. So that's going to be the second video today. And then the third video is the stuff that's relevant for Lab 1. So we'll talk through the relevant topics for Lab 1, and then we'll actually talk through Lab 1 itself. We'll look through Lab 1 itself. So that's the plan for today. So let's go ahead and start by talking about the lockout tag out system. And usually I would start this conversation, if we were in person, I would ask you all in the class if anyone has worked in an industrial or manufacturing environment before, or if you've had an internship in an environment like that before. And usually a few people have in the class. And so then I'll ask those people, have you ever heard of the lockout tag out system? And usually they'll kind of nod and say, yeah, we've heard of it. And then I'll ask them, have you gotten any training on it before? And usually, if they were in an internship or a short-time role, usually they'll say, a little bit, but not very much. And that is about the same as my own experience. When I had an internship, when I was an undergrad, I had 2 internships. In one summer, I was an intern at a manufacturing plant that made washers and dryers, that made Maytag washers and dryers. And at another plant, the next summer, I had an internship at the plant that made Amana refrigerators. So 2 kind of manufacturing big facilities. And I do kind of remember being an intern and getting a little bit of training on the LOTO system. But basically, the training that I remember was pretty much like, if you see tags that look like this, like a red or a striped tag or something like that, if you see a tag that looks like this, don't touch it. That's pretty much the extent of training that I got on the LOTO system when I was an intern. And quite honestly, if you're an intern or you're a short-time employee or something like that, that's probably all you really need to know if you're just working around the tags or the LOTO system and you're not really working on those components. But I guarantee if you are working in an industrial environment at some point in the future, you'll get some more training on the lockout tagout system. All right, so with that, let's go ahead and get started. So I'm going to share my slides. All right, so it's called the lockout tagout system because it involves locks and tags, and you're taking some piece of equipment out of service so that that piece of equipment can be repaired or maintained or something. And basically, in a nutshell, you want to make sure that piece of equipment that somebody's working on doesn't inadvertently start or become energized and hurt the person who's working on it. As a side benefit, you also don't want that machine to start because it could damage the machine as well if some piece is missing from it while it's being repaired and it starts. But really, it's about the people. It's about protecting the people that are working on the equipment. All right, so here's a little bit of motivation. All right, so let's say you're doing a little bit of electrical work on your house. Let's say something fairly simple. So let's say you're going to install a ceiling fan in your house. I've installed, I don't know how many ceiling fans in my homes over the years. So it's pretty straightforward, but what's the first thing you want to do when you're going to install a ceiling fan? You want to make sure that that light socket up there has no electricity. I don't want to be putting my hands up there with a screwdriver and screws and things when there's 120 volts AC up there, just preparing to shock me and knock me off of the ladder that I'm working on. So the first thing you want to do is make sure that it's de-energized. Now, one way of doing it would be to go over to the light switch and turn off the light switch. That will de-energize the wires going to the light switch in the ceiling, but do you think that's a good idea? That's probably not the best way to de-energize that because, like I said last time, I have 4 kids. So what happens if my 5-year-old walks in the door and says, "Daddy, why are you working in the dark?" and then flips on the light switch? Well, then I get an unpleasant surprise. So just the light switch alone, just flicking it off is probably not the best solution to de-energize something. Likewise, if I'm working on a larger piece of equipment, say a generator or a CNC lathe or something, probably the best way of de-energizing it is not just to push the off button. You want to be a little bit more secure than that. So what do? I go down to the circuit breaker box in my basement and I find the correct circuit breaker. Sometimes takes some trial and error because they're never labeled well enough. And you find the right circuit breaker, you switch it off, and then you test out the light, right? So an easy way to test whether you got the right circuit breaker is to use the light switch. Does the light turn on? If not, then you probably got the right circuit breaker. Frankly, I don't think that's good enough. I don't have a multimeter right in my arm's reach, but I have several multimeters at home, and so if I'm going to work on electricity, I am always going to do a check with the multimeter to make sure there's no voltage present, and that's a good idea. But also, another point that I want to make is that as I'm turning the circuit breaker off, it's unlikely that anybody in my home is going to go down to the circuit breaker and flip the circuit breaker back on. I'm not too worried about any of my kids or my wife, unless they're really mad at daddy. If I didn't give them dessert last night or something, I'm not too worried about anybody going down there and flipping the circuit breaker back on. So for a really small scale, like a residential scale, I'm not too worried about making sure that circuit breaker stays off. I'm pretty confident it's going to stay off. I don't feel the compelling need to take a lock, to take one of these locks and lock the circuit breaker in place so it stays de-energized. I'm fairly comfortable on a residential scale, just flipping the circuit breaker off. All right, so if there's only one person working on the equipment, then it's pretty easy. Just unplug it or flip the circuit breaker or something to make sure that it stays de-energized. All right, so now let's go a little bit more complicated, and I think maybe an intermediate step would be back when I was working on a wind farm for GE. All right, an individual wind turbine is a pretty complex piece of equipment, but normally we would have 2 to 3 people working on it at the same time. Never one, like I said last time, always at least 2, sometimes 3, depending on what type of maintenance or repair we're doing. So when you've got 2 or 3 people working on a piece of equipment and you have a lot more circuit breakers, a lot more components in that piece of equipment, it becomes a lot more difficult to keep track of what should be de-energized and what is okay to energize. Especially when you've got maybe some people are working on this component over here, you know, a motor in the pitch system of the blades, and then maybe somebody else is working on a different system over here. They're working on the, you know, I don't know, the anemometer, the yaw motor, the generator brushes, something like that. And so it's hard to remember what exactly needs to be de-energized for this person's work and what needs to be de-energized for this person's work. What happens when one of the people finishes and he's ready to re-energize the stuff for his maintenance, but this other person is not done with their maintenance. They need that stuff to be, some of their stuff to be de-energized. So it becomes really difficult to remember what needs to be de-energized and what doesn't need to be de-energized. And if you go to an extreme, if you've got a factory, you know, an industrial environment, you've got thousands of circuit breakers, thousands of valves, because by the way, this is not just about electricity, this is about mechanical systems as well. It's about, you know, steam and high pressure air and things like that as well. So you got simultaneous jobs going on. You might have, you know, dozens of maintenance jobs going on all at the same time. A good example of this, when I was on the aircraft carrier, when I was in the Navy, we went through a couple of shipyard periods. Well, a couple of maintenance periods and one shipyard period. And when we were in the shipyard, you know, most of everything, maybe not everything, but most things were tagged out at some point because some maintenance or some repair was happening on virtually every system on the ship at some point. So there are thousands, not exaggerating, thousands of tags hanging throughout the propulsion plant and the ship. And it's impossible for any person to keep track of what should be energized, what should be de-energized. So at that point, you need a formalized system. And frankly, that system needs to be computerized, and it was. So it was all in the computer, what jobs were going on and what things need to be de-energized to enable those jobs to happen. So we need a formalized system, and that system is called LOTO, lock, out, tag, out. And LOTO is kind of a general term. It's a term for the process by which companies make sure that the machinery that is being worked on remains de-energized, thereby protecting the people who are working on that machinery. The exact LOTO process varies a little bit, and I even saw that in the different places where I worked before coming to ISU. The exact process, step by step, that varies a little bit by company. But in general, the procedures are similar wherever you go. So it ensures the equipment's de-energized and stays de-energized in order to protect the people that are working on it. And a side benefit, it also protects the equipment, but it's about protecting people. This is what I just said. It's to prevent injury to employees. And the lockout tagout program, it's mandated, or an energy control program. This is the second bullet point down here. An energy control program is mandated by OSHA. the Occupational Safety and Health Administration. So OSHA doesn't tell you exactly what steps you have to take. Every company can define their own procedures for the LOTO system, but every company must have something similar to this to ensure the protection of their employees. So if you go out and work in industry, if you work in an industrial environment after graduation, I guarantee you will have training on the lockout tagout system. I promise you. So this is what we want to prevent from happening. The person on the right, that's a test dummy, so don't worry. That person is not a real person. That image is just to demonstrate the company that's making that PPE. So they're demonstrating how their PPE can protect employees. Although I don't care what kind of PPE I'm wearing, I don't want to be in a position where I am in the same position as the test dummy there on the right. That's not a good day. The picture on the left, I don't know, that looks like a real person to me, so I hope that person's okay. So this is what you don't want to happen. If something like this does happen, then a mistake was made somewhere. All right, so we're going to go through the procedural steps. There are 9 steps in general to the lockout tagout system. And like I said, they will vary a little bit from company to company. But I want you to know the general procedure for lockout tagout. That being said, here's the level of detail that I would want you to know. If I gave you, say on an exam, if I gave you a list of the 9 steps, you should be able to put them in order. If I asked you about one step in particular, you should be able to describe that step and explain why you do that step. I am not going to ask you an essay question where I say, list the steps of the lockout tagout system in order. I'm not going to do that. That's kind of silly. Besides, you could go back to this slide and just list them. So I want you to be able to put them in order. I want you to be able to explain why we do what we do. Okay. All right, so let's get going. There's 9 steps here. So number 1 is somebody identifies some piece of equipment that needs to be worked on due to repair or maintenance, something. Then the next step is that an employee, probably the employee who's going to do the work, they need to identify how to completely isolate that piece of equipment. Not just electrically, although that's the main part of what we're talking about in this class, but it's not just an electrical program. It's mechanical and gravitational and all types of potential energy that could be applied to the machine and hurt the person. So needing to figure out how to completely isolate that system. For electrical components, we're probably talking about circuit breakers or fuses, probably. And for mechanical systems, we're probably talking about valves, shut certain valves, most likely. So that's step 2. And then step 3 is that somebody double checks the plan for isolating that piece of equipment. Different companies do it differently. When I was in the Navy, it was a second maintenance worker that would do the double check. When I was at GE, it was me, the site manager, who would be the double checker. So I had to make sure that the isolation plan that the technicians working for me were going to do would be adequate. So it's quite a bit of responsibility. If one of your technicians get hurt, you messed up. The manager messed up. All right, so the double checking is very important. Everybody makes mistakes sometimes, so you need to have multiple layers of people to check and catch any mistakes that were made earlier. Here's an example of a wiring diagram, just giving you an example of how you would look to isolate something. I know this is not really very legible. That's fine. I'm just trying to show you an example here. So let's say, let's take a simple thing. By the way, this is a wiring diagram for an electric motorcycle. And I didn't mention last time, but I have an electric motorcycle. I built it. Well, I converted it. It's a electric Harley Davidson, and it's in the lab next door. It's in Turner 132. If you're interested in it, feel free to stop by, and I'd be happy to show it to you. It's an electric Harley Davidson 1979 Sportster that I converted about 9 years ago now to electric. Anyway, so this is not the exact wiring diagram for my motorcycle, but it's fairly similar. So let's say we want to something silly. Let's say I wanted to replace the horn. I don't want a horn that goes, I want a horn that goes, something like that. So here's the horn right here, and I want to remove that horn. But that horn could have 12 volts applied to it. And even though we know from last time 12 volts is not going to kill me, it can still hurt, and I don't necessarily want to work with it if it's energized. So somehow I need to de-energize this horn before I remove it and replace it with something else. So what you do is you look at, well, how is that horn getting electric power? And so you go and back up. Let me get my cursor. When I go like that, when I'm moving my cursor around, it's because my cursor hides if I don't move it in a little while. So here's the horn. This is the push button switch that I push to activate the horn. So if there's a way to make sure that no one can press that horn, then that would work, just to make sure that 12 volts is not applied to that horn. So if there's a way to isolate that push button switch, then that would work, possibly. Or if I want to go upstream from that, it comes from over here. This is a fuse. So this is probably the best way. This is a fuse for the 12 volt system, because all of this over here is the 12 volt system, like lights and turn signals and things like that. And you just get a fuse puller, like a pair of tweezers is what a fuse puller kind of looks like. So you take your fuse puller and you grab that fuse and you pluck it out. And after you have removed this fuse right here, then there is no way that 12 volts of electricity could be applied to the 12 volt system. And you have guaranteed that everything in this 12 volt system will remain de-energized. That's probably the best way, is to remove that fuse. Then you can work on anything over here and feel safe while doing it. There are other ways, of course. There are usually multiple ways that you could de-energize something. So this is the DC to DC converter that takes the pack battery voltage, which the batteries are down here, so it's probably somewhere around 72 volts. That's what mine is, nominal, around 72 volts. And so you could, anyway, that DC to DC converter takes the pack voltage around 72 volts, steps it down to 12 volts so that it can operate the 12 volt system, like the headlights, taillights, horn, things like that. That's what this is. And then that goes to the key switch. This is just literally the key that you plug in and turn the system on. So another way of guaranteeing that this is not going to receive power is just turning off the key and making sure the key is not in the ignition. So that would actually work too, and that would probably be the easiest way, actually. As long as you can make sure that nobody's going to take that key and accidentally turn it on. So in the case of a motorcycle, I'd feel pretty safe doing that. In the case of a much larger system where you might not be able to see the person who would take a key and turn something on, then you need to be a little bit more careful. And of course, here's another fuse. This is the main fuse. This is a big honking fuse. This is a 400 amp fuse. That's a big fuse. So that'll be a little bit more difficult to remove. But any of those ways that we just talked about, you can remove. So that's your plan. If you're going to work on the horn, then either that or that or that or that is your best bet for ensuring that the horn is de-energized and remains de-energized while you're working on it. All right, so that'd be the plan. Okay, so now there's a plan and there's a second checker. Somebody has second checked that plan to de-energize. Now, depending on the company, you have to get permission in order to commence the work, and excuse me, to commence de-energizing the system. Sorry, you're not commencing the work yet. You're just de-energizing things. You're tagging them out. So depending on the company, you might need to get permission before you do that, because that might be critical to some other thing that needs to remain running. So you might need to wait until a maintenance period, like you're in dry dock or something. But when it's ready to commence, then you go ahead and you de-energize the system, you pull the fuses, you switch off the circuit breakers, you close the valves, whatever you need to do to isolate the system. As you do that, it's really important not to just turn off the circuit breaker. You turn off the circuit breaker and then you lock it. So a lot of circuit breakers in industrial settings will have a hole in the circuit breaker that allows you to insert a lock in the circuit breaker, and you can lock it in position. But you shouldn't just do that. You shouldn't just have a lock. You should also have a tag. So what you should do is have a tag. You should not fill it out in permanent marker. You should fill it out in marker that is capable of being erased, depending on the company, depending on the policies. But in this case, somebody wrote it in permanent marker. I'll let you guess who. So if you were going to de-energize the circuit breaker, you put the lock through the circuit breaker, and then you would take the tag and you write who is doing the work and what work is being done, and you put this right there, and then you lock it. And now you take the key, obviously, with you, and now that circuit breaker is locked in the de-energized state. And if somebody comes along and says, oh, why is that circuit breaker locked out? And there's a tag right here that tells them exactly what's going on and who they can contact if they have any questions about the work. Okay. So whenever possible, you use locks. There are times when that's not possible. And if you can't lock it, then you need to at least tag it, at least put a tag there. And then step 5, again, depending on the organization, somebody is going to second check that it was de-energized properly. And you might think this is silly and redundant, but let me tell you, I have seen a number of times personally where somebody initially de-energized the wrong thing. Especially when I was in the Navy on the ship. We have thousands of circuit breakers on the ship. So it's not that hard. You know, you're at the end of a 12-hour shift or something like that, and you're hanging these tags and de-energizing something. You're looking for the right circuit breaker, and you look down and look back up, and then you operate the circuit breaker and you flip the wrong one. It happens. Unfortunately. So it's important for that second checker to go and look and make sure the tags were hung and the circuit breakers were de-energized in the proper locations. Okay, so that's the second checker. Again, that depends on the organization. This is important. It's important that each lock have only one key. So you don't want a situation where some other maintenance worker could, I mean, they shouldn't and they probably wouldn't, but you don't want to even have the possibility of some other maintenance worker having another key that works for this lock and being able to unlock this and remove the lock. You want to make sure that the person doing the maintenance is the only one who has that lock, that key for that lock. All right, so there's only one key for each lock. That naturally brings up the question, what if that person loses the key? It's a natural question. The short answer to that is it's going to be a long day, because you will find that key, or somebody will find that key. If there's no way of finding that key, you know, if the key, if you looked for a long time, you can't find the key, then eventually, you know, there's going to be someone in a position of authority that makes the call. All right, we're going to cut the lock with bolt cutters. But believe me, before you go to that resort, you're going to spend a long time looking for that key. So you don't want to lose the key. So it's very important that there is only one key for each lock. And it's also very important that there is one lock per person, per piece of equipment, per component, I mean, all right? So if, let me give an example to make it more clear. Let's say there are two people working on a piece of equipment, a CNC lathe, for example. So they're doing some maintenance on a CNC lathe, two people. They're both going to be working on it. And in order to de-energize the CNC lathe, there are two circuit breakers, all right? There's two sources of power, maybe a primary and a backup to that piece of equipment. And you need to isolate both of them, both the primary and the backup source of power, all right? So if you think about how many locks are there going to be, all right? So there are two people, they're both going to be working in there, and there are two sources of power, circuit breakers, that need to be de-energized. So both people that are working on the equipment need to put a lock on both of those sources of power. All right, so two people, two sources of power, each person needs to put one lock on each source of power, so there's going to be 4 locks. All right, I hope that example made it make sense. If there are 3 people working on a job and there are 3 sources of power, 3 circuit breakers that need to be tagged out, each of those 3 people need to put a lock on each circuit breaker. There'd be 3 locks on each circuit breaker, so 9 locks in that case. And now you might be asking, how do 3 people each put a lock on a circuit breaker? Good question. So we have things that are called hasps, like this, and this is designed to do precisely that. So if I've got a circuit breaker that has 1 hole in it, I'd turn off the circuit breaker, I'd put this in there, and then I've got a place to put my locks in each one of these holes. And now I've got a place for up to 6 locks on here. If you need more than that, which is unusual, but if you need more than that, you can put another hasp in one of these holes. And now you've got 5 here plus 6 in the other one. Now you've got 11. And you can keep on daisy chaining these if you really want to. So that's how you put more than 1 lock on a piece of equipment. Okay, hope that's clear. It's very important. 1 key for each lock, 1 lock per person, maybe it'd be clearer down here if I said per component, because I don't mean like the piece of equipment you're working on. I mean the component that's de-energizing that piece of equipment. All right, maybe that would be more clear. 1 lock per person per component that is de-energized in order to de-energize the piece of equipment. All right, hope that's clear. Let me know if it's not clear. Okay, the next step, we're on step 6. We're almost 2/3 of the way done. Step 6 is a really important check, though. It's called a hot, cold, hot check. Let me find my multimeter probe so that I can do some demonstration. I don't have a black pen. Here's a pencil. This is good enough. Okay. So in order to perform a hot, cold, hot check, you're going to be working with a multimeter or a voltage probe or something that will detect voltage. And you need to make sure that the equipment that you're working on is de-energized. So in other words, you're making sure that whatever you did to de-energize it, you didn't miss anything. So you're it's a last check before you put your hands in there and start working on it. It's a last check to make sure there's no voltage in there. You're not gonna shock yourself. So this is the procedure for performing a hot, cold, hot check. It's not just that you take your voltage probes and you stick them in there and check for voltage. It's more than that, all right? Because we want to guarantee that the multimeter or voltage probe that I have is working properly, all right? So this is partially about, the big picture is making sure that piece of equipment is de-energized, but in order to do that, I need to make sure that my multimeter is working properly when it tells me that there's no voltage inside there, okay? So here's the procedure for a hot, cold, hot check. I take my multimeter or my voltage probe or whatever I'm using, and I go to a known energized source. Often we would just use an electrical outlet. So use a 120 volts AC outlet. Take your multimeter probes and you put them in the electrical outlet. And it should measure 120 volts AC, about, because that's about what the outlet is. And so if I do that, then I know my multimeter, my voltage probe, is working. All right. Then I take my multimeter. After doing that, that was step one. Step two is you do your cold check. That's where you go to your piece of equipment that you're actually going to work on, and you measure the voltage inside that cabinet or on the piece of equipment, whatever it is you're working on, and it should be de-energized. If it's not, then you stop and you back up. You go back to step one and redo this. But step two is taking the multimeter, measuring the equipment. It should be de-energized. That's the cold part of the hot, cold, hot check. The third step is making sure that multimeter is still working properly. So you take your multimeter, you go back to some other energized source, and you check that it's still working. It measures 120 volts AC or whatever it should be. So what you're doing is you're taking your multimeter, you're checking that it works on some other energized piece of equipment. Check that it works. Then go to the de-energized equipment you're going to work on, check that it's de-energized. Then take your multimeter and go back to some other piece of equipment, electrical outlet or whatever, and check that it works. Your multimeter works. What this reminds me of, so I hear, from my understanding, police officers, when they're running radar, my understanding, when they run radar, if they're going to get you on a speeding ticket, they've got to do some calibration or check of the radar gun before they run radar and catch you speeding. So beforehand, they do a calibration check. Then they sit there on the side of the road and catch you speeding by running radar, shooting a radar gun at you, and catch you speeding. And then after that, once again, they have to check the calibration of their radar gun, make sure it's still working. So that's kind of similar, kind of idea. You got to check that it's working, then check the thing that you're interested in, then afterwards check again that your equipment is still working. All right. This is I have seen this over the years. This is a source of confusion for students. I've seen all kinds of permutations of what you check and when and why you check it. But what I just explained is the proper order and purpose of doing a hot, cold, hot check. All right, step 7 for our purposes today, that's the easy part. In reality, that sometimes, not always, but that might take the longest is actually performing the work. Although not always, maybe the work is really easy and it takes longer to get ready to do the work than it does to actually do it. But anyway, step 7 is actually do the work, which we're skipping over for our purposes. And then step 8, once the work is done, then depending on the organization, you get permission to clear the tags, undo the locks, and restore the circuit breakers or valves to their normal position, whatever normal might be. And then step 9, depending on the organization, you get a second person to go around and double check that the tags are removed and that the locks are cleared and that all the breakers and the valves, fuses are all returned to their normal state. We did all these second checkers when I was in the Navy because it was a complex piece of equipment. A nuclear plant in a ship is a complex piece of equipment. So we did all these second checkers, and you'd be surprised how many times the second checker found something wrong. All right, so there's a bunch of ways that you can tag something out. There's not only locks, there's also these hasps that I mentioned before. We've also got this type of thing. So if you've got, this is for probably a simple application. Let's say there's a band saw or a drill press or something that I want to tag out to do some work on the motor or something. So in that case, well, it's just got a plug that plugs into the wall. That's the only possible source of power. So it's pretty easy to tag that out. All you do is you take the plug that plugs into the wall, put the plug through this hole right here, and then close this up. You can see there's a hole right there. There. So just put a lock through there, and then as long as that lock is on there, nobody's going to be able to plug it in. All right, so there's an example of a circuit breaker over here on the right. Some circuit breakers have holes in them so that you can put a lock or a hasp through it. Even the ones that don't have a hole through them, there are covers for the circuit breakers that you can lock into position, and that's what's being shown here. So this circuit breaker doesn't have a hole in it, but you can you can de-energize the circuit breaker and then put a cover over that de-energized circuit breaker and lock it so it stays in position. And that's what's shown over here on the right. This is like a knife switch that you can move up and down, and it's locked in position. Remember, one lock for each person per component that's being locked out, and one key for each lock. And just a reminder, LOTO, it's not just for electrical systems, it's for all kinds of any type of system that could energize in any way a piece of equipment that you're going to be working on. So it's for hydraulic and mechanical and gravitational steam systems, all kinds of different systems. Okay, I'll show you now just a quick example of a form that needs to be filled out. There's documentation that goes with this because it's an important procedure. So I'm gonna show you a physical form example. So I'm gonna switch cameras. Okay, here we go. This is just an example. I just wanted to show you, I thought you might find it interesting. This is the actual lockout tagout form that we used to use at GE when I worked there. So it's basically got all the different steps. Like I said, every company is a little bit different, so it's not going to be identical, but it's basically got all the steps that we just talked about. So you fill in the basic information, what is being worked on, who's doing it, types of energy sources, you notify all the employees, identify all the sources of stored energy, you deactivate everything, including electrical power, pneumatic, hydraulic, steam, gravitational, cooling water, gas. You deactivate everything, de-energize everything. Then you try this hot, cold, hot check. So if you needed proof that I didn't just invent that term, here it is. This is a hot, cold, hot check. That is a real industry standard term. Everywhere I've gone in industry, they do hot, cold, hot checks. So you verify that and check that it's done. Then you try it out by measuring the piece of equipment, make sure it's de-energized, and you initial here. You're kind of like signing, you're authorizing and guaranteeing that you've tried this out and the equipment is de-energized. And once again, then you're signing here, and this is your guarantee that you have done all this properly. It's a big deal. If something were to happen, they want to be able to trace it back to somebody. Then after the work is done, then you re-energize everything. You replace all the equipment parts. You remove locks and tags, and you check that you've done it. Control devices removed, energy reconnected, employees are notified. So this is a piece of paperwork that has to be completed for every single time something is tagged out for repair or maintenance. And then after that's completed, that form is kept on file for a certain period of time. I don't remember. That's probably a company policy type thing. I don't remember if it's a year or 5 years or something like that. And it goes into a file, and the hard copy is kept for a certain period of time for records, so that if or when you are audited by OSHA, and that happens, it does happen periodically, you can produce all of those forms and you can show that you're following your stated LOTO procedures. Okay, that's it for LOTO. That is definitely part of electrical safety. So that's going to be the end of what we're talking about in terms of electrical safety in this class. And I'm going to stop this video now. And in the next video, we're going to talk about a review for Lab 1 so that you're ready to do Lab 1. And I'm also going to do a little demonstration of Tinkercad because I'm going to assume that you haven't used it before. Some of you probably have, but I'm going to assume that you have not used it before. And so I want to make sure everyone's up to speed with Tinkercad before we start on Lab 1. All right, so that's it for this video. I'll see you in the next video.